So the binomial theorem in algebra is just an efficient way for us to be able to expand out binomial powers. Okay, so for example, x plus y squared expands to x squared plus 2x plus xy plus y squared. X plus y cubed, when we combine all the like terms, we get x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, and for power 4, etc. Now, you may see some sort of patterns evolving here. One of the ones that you might see is this power on x seems to descend from 2, 1, and in fact, you can put power 0 there. For 3, it goes 3, 2, 1, 0, 4, 3, 2, 1, 0. And you could also see the reverse is happening for y. So the y's go 2, 1, 0, 3, 2, 1, 0, 4, 3, 2, 1, 0. Okay, so that's one part of the binomial theorem, is if you can recognize the pattern of the powers. But the other part of this is the coefficients. The coefficients happen to follow Pascal's triangle. So if we take a look at this row 2, we get 1, 2, 1. Row 3 gets 1, 3, 3, 1. Row 4 is 1, 4, 6, 4, 1. In fact, row 1 would be 1, 1, and row 0 would be 1. In fact, here's Pascal's triangle over here. And you can see that those coefficients show up in these powers. Okay, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. The next power, or expansion of power 5, actually just follows the 5th row of Pascal's triangle. Power 6 expansion just follows the 6th row of Pascal's triangle. So we can use this Pascal's triangle and the pattern of powers to help us expand these multiplications, these binomial powers. So I really would not want to expand this by doing a plus b, foiling that out, times b, foiling that out. We really just wanted to have a more efficient method of calculating this expansion. And to do this, we just use our 5th row. So I'm just going to go to my 5th row here. My 5th row is 1, 5, 10, 10, 5, 1. So I'm just going to go 1, 5. Let me write this a little closer together. 1, 5, 10, 10, 5, 1. Okay, and this allows me to get my expansion coefficients. And the powers on the power part of this is fairly straightforward. We get a to the power 5, b0, plus a to the power 4, b1. Notice that the powers always add up to the original power of 5, and it's in descending powers of a, increasing powers on b. So we get plus a3b cubed plus 10a squared, sorry, that's going to be a cubed b2. We get a squared b3 plus a1 b4 plus a0 b5. So there's our expansion. We don't really need the power zeros, but I just put them in there just to highlight the pattern of powers here. For power 6 expansion, we just go to row 6. Okay, so there's 7 terms in row 6. So I'm going to write my coefficients. It's going to be 1, 6, 15, 20, 15, 6, 1. Okay, and then I just use the pattern of powers to get the power parts here. So it's going to be a to the power 6, b0. In fact, I'm just going to leave the b0 out. We're going to get a to the power 5, b plus a to the power 4, b squared, plus a cubed, b cubed, plus a squared, b4, plus ab5, plus this is going to be b to the power 6. So there it is. There's my expansion. I don't have to FOIL out and combine a whole bunch of like terms. This all has the coefficients have the like terms all combined. This is a much more efficient way of doing this expansion now. So for power 3, in this case now, my a's and b's have other coefficients involved, and there's also a minus in there, so I have to be wary of this. So I'm just going to do my coefficients first. So it's going to be 1, 3, 3, 1. Okay, so that's my expansion coefficients for the third row of Pascal's triangle. Okay, so then doing the power parts, I'm going to have 2x cubed, and then this is going to be negative 3 to the power 0. I don't really need that part. I get 2x squared, negative 3 to the power 1, plus 2x to the power 1, negative 3 squared. And just going to move that over a little bit, plus my coefficient is 1. It's going to be 2x to the power 0, negative 3 cubed. Okay, and then I just simplify this expression. So this becomes 8x cubed plus, this is going to be 2 squared times 3 times negative 3, so that's going to be negative 36. So negative 36x squared plus, this is going to be 3 times negative 3 times negative 3 times 3 times 2, so that's 54. X to the power 1. Okay, plus that last term is going to be minus, it's going to be just 27. Okay, or negative 3 cubed. Okay, so this is how we can expand these without having to do all this FOIL and collecting like terms.